There's also a two-way ANOVA. So suppose a researcher felt that the children's sex was also a factor in the language performance. So in addition to the four categories, each age group would be divided into a group of males and a group of females. So this would be a 4-by-2 design. So we have the 5, 6, and 7-year-olds, and then looking at males and females. Resulting data analyzed using a two-way ANOVA, where one variable is age and the other is sex. The researcher is asking more than one question. First, is there a difference in language performance among children of different ages? Second, is there a difference in language performance among children of different sexes? Both questions concern so-called main effects in the ANOVA, but there is an additional question which is implicitly introduced. Is there an interaction between age and sex with respect to language performance? The ANOVA has to examine three sources of variance: the variance across age, the variance across sex, and the variance of the interaction between age and sex. And it has to compare each of these sources of variance with the variance within now 8 groups. So the 5-year-old males, the 5-year-old females, the 6-year-old males, the 6-year-old females. So now we've moved up to 8 groups. 3 F ratios are calculated: an F ratio for age, an F ratio for sex, and then the F ratio of the interaction. Any or all may be statistically significant. Interaction variations are not attributable to any of the main effects acting alone, but to the joint action of 2 or more variables. So here we go. Now we have 8 groups, and we look at the mean and the variance within each group. And we have null hypotheses. There's no difference between the means of the males and females. Here's another one. There's no difference between the means of the various age groups, right? And then we have to look for the main effect. So in this example, the F for the main effect of age indicates a significant difference among ages. The F for the main effect of sex indicates significant difference between sexes, and there was an interaction effect between age and sex. Now we can make it even more complicated. We could do a 3-way ANOVA. And then we have even more interactions. So let's look at a study that might look at sex, clinical classification, and length of time in treatment, or some sort of outcome variable. The ANOVA in this situation considers the following main effects for interaction: sex, clinical classification, and length of time in treatment. So now we've got, look at what we're looking at. How complicated is this? Then we have to do, so we're looking for 3 main effects, and then we have to look at all these different interaction effects. Again, we have the computer do this. Most studies do not involve interactions of more than 3 variables. More complex interactions are difficult to interpret. Sample size and other design considerations need to be looked at. With ANOVA procedures, if a significant difference occurs amongst the groups in the study, further analysis may be conducted to ascertain the location of the significant differences. So like if you find a difference, you can do another statistic to look further into the differences. So they used to do t-tests, or there are other more fancy statistics, the Tukey, the Duncan, the Newman-Kuhls, the Schufet procedure. So you may find that research reports contain references to these analyses following ANOVA in order to identify specific differences. We're almost done, sorry. Non-parametric procedures that are more or less parallel to an ANOVA. So for each ANOVA we do, if I hadn't already mentioned it, ANOVA is a parametric statistic. There are also non-parametric statistics that you could use. For a one-way ANOVA, there's Kruskal, Wallace, the Freeman two-way ANOVA, the Cochrane Q test, and the chi-square test for independent samples. So if your data doesn't meet the criteria for a parametric statistic. This is the summary table that I had spoken about earlier. You should print it out. So copy it from the PowerPoint and just paste it into Excel and then print it out. What I like about this is it shows, again, we have our 4 scales of measurement, nominal being the most basic, ordinal, then interval or ratio. And then we have a way to analyze relationships and a way to analyze differences. So for analyzing relationships, remember that's when we were looking at how things move together, and analyzing differences when we're looking at, so analyzing relationships would be correlations, and analyzing differences would be inferential statistics. And then we'd have